Hello students, you are welcome to our regular class on SLM 305. Our topic today is a continuation of what we had last week, soil microorganisms. And we are going to talk on nematodes, earthworms and termites. These are higher levels of soil microorganisms that you can see with your naked eyes. They are valuable in the soil and they provide so many activities and they have so many functions that they perform in the soil. In addition, they equally affect the performance of soil in one way or the other. It's an interesting course, it's an interesting topic. I want you to feel free and enjoy the course as I take you through the slides. God bless you. I am your facilitator for this course, Excellent 305 for this session. Godwin A. Al-Hassan of the Department of Crop and Soil Sciences, National Open University of Nigeria. God bless you. This is a picture of a termite mound that is as tall, could be as tall as a 3 meter, and the base could be as wide as 8 meter. The color of the termite mite is similar to the color of the parent soil material. As I earlier told you, our topic today is on nematodes, earthworms, and termites. And in addition, we have added soil organic matter. By way of introduction, nematodes, earthworms, and termites are some other organisms that dwell in the soil. Nematodes are microscopic, while earthworm and termites can be seen with the naked eyes. They affect crops and thus have interactions with the soil. This topic is dedicated to the explanation of the activities in the soil. Nematodes. These are microscopic in size. They are like worms, worm-like and spindle-like in shape. The importance of nematodes in soil is not other related to soil fertility, but that some are pathogenic to some agricultural crops. They usually infect the roots of such plants, thereby interfering with normal physiology, obstructs water and nutrient uptake. The plants infected are mostly horticultural crops like tomatoes, carrots, ornamental, and fruit trees. Earthworms. These are the first known larger animals in the soil. They thrive best in most soil with abundant supply of organic matter. They are very important in the fertility of the soil because they add in humus formation by ingesting some organic debris and later ingesting same as wormcasts. The wormcast usually contains high amounts of organic matter like nitrogen, calcium, magnesium, and phosphorus. Earthworms help in the process of soil formation by building new topsoil every year. They equally help in water infiltration, aeration, and reduces soil erosion. This is a picture of nematodes. They are spindle-like, some are roundish in shape. And then this is the way they affect the roots of our plants. They interfere with the normal uptake of food nutrients, including water. Termites. The presence of termites is one of the characteristics of most tropical soils. Termites exhibit very great diversity in their feeding habits. Some feed on organic residues, some on wood, and some cultivate fungi in their nests. Uh, there are different forms of termite nests. Some build huge nests of about 3 meters in height and 12 meters in diameter. The population of nests per hectare could be as high as 3,000 per hectare. Importance of termites. Physical effects. They carry only finer particles, thereby leading to increase in the finer structure of the soil. The mound materials are more stable and better aggregated than the surrounding soil, thus affecting the structure of the soil. Because of the numerous underground tunnels they create, the bulk density of the soil is reduced. The mound contains finer particles like clay and high organic matter. the water holding capacity is equally increased. These are two pictures of the termite mounds. You can see the color. One is they take the color of the parent material in the soil. They could be as high as 3 meters tall and as wide as 8 to 12 meters in diameter. And so the soil around the base are always very clay. They contain more of the clay than other materials and are equally very fertile. And the level of infiltration of water and aeration is equally very high. Chemical effects. The soil pH is higher in the mount material because of accumulation of calcium carbonate. Organic matter is higher than in the adjacent soil. The termite mound contains higher amount of magnesium, phosphorus, calcium, and potassium, thus improved soil fertility. Pedological effect. Termites contribute to formation of gravel and soil-free horizon. Up to 360 kg per hectare per year of soil materials can be turned over through the activities of termites, thus helping in soil formation. Activities of termites lead to the formation of 3 centimeter thick of soil every 100 years. Organic matter. By way of introduction, organic matter determines soil nutrient level. It contains the amount of other cations such as potassium, calcium, magnesium, and micronutrients such as zinc, boron, copper, and anions like phosphate and nitrate and chlorine. The soil organic matter consists of fresh organic materials and humus. The fresh organic material is transformed by soil organisms into humus. In the process, nutrients are released into the soil. This is a picture of an ideal humus soil, very frail and highly aerated and can easily allow water to penetrate. A humus soil is ideal for crop production, well aerated, drains freely, and contains adequate nutrients, both macro and micronutrients. What are the needs for soil organic matter? Its needs have become even more relevant in modern times due to the following reasons. The ever-increasing cost of commercially manufactured fertilizers, increasing organic residue from both crop and the farms, greater awareness of the need for ecological conservation of resources and environmental safety, introduction of zero/minimum tillage practices, greater agricultural production from both crop and livestock to meet the nutritional and fiber needs of the population. Disadvantages of organic matter. It may provide the source of pathogens for root-borne diseases, e.g. nematodes, insects, etc. Crop residues low in nitrogen and other essential nutrients can result in immobilization of available nutrients and therefore affect their uptake for crop growth. Toxic levels of some substances can be released early in the organic matter decomposition, and this may affect crop growth. The role of microorganisms in soil organic matter. Microorganisms get their energy and nutrients by eating, that is, decomposing soil organic matter. This decomposition results in the following: the use of some of the carbon, nitrogen, and other elements by the microorganism, the release of carbon dioxide, water, and other elements to the soil solution and the atmosphere. Humus. Bacteria and fungi are the most active organic matter decomposers but are aided by actinomycetes. Bacteria and fungi work optimally in moistened soils at temperatures of about 35 degrees centigrade and soils of neutral pH. The role of organic matter in tropical soils. The soils of the tropics are generally low in fertility. This is partly because the soil is composed of low activity clays that are not very rich in cation exchange sites. Hence, one of the major ways of increasing the cation exchange capacity of the soil in the tropics and fertility is to add organic matter. Roles of organic matter in the soil. Organic matter functions as an exchanger or sorption agent, especially in soils with naturally very low cation exchange capacity. Organic matter functions as a buffer system for pH value and ion concentration. It is a nutrient carrier because the small amounts of calcium and magnesium and available phosphorus in the oxalos and autosols of the humid tropics and most savannas are concentrated in the humid topsoil. Organic matter also works as a slow release source of nutrients, thereby reducing the risk of leaching. The role of organic matter continues. Humidifying organic matter works to combat toxic metal concentrations by forming stable complexes with a high molecular weight. Organic matter improves the water holding capacity of soil. Organic matter improves soil structure. Organic matter is essential as a habitat and source of nutrients for microorganisms and for soil fauna as earthworms and termites. Types of organic matter. Crop residue is one. It includes straw, stalks and roots, green manure, the leguminous crops. Number three, animal manure, the waste. It could be solid or liquid, easy, poultry droppings, piggery droppings, livestock dung, etc. etc. The sewage sludge, municipal waste. These can be treated, concentrated, and made into commercial fertilizer. Composite, combination of manure, sewage sludge, leaves, grasses, cuttings, etc. Pairs, naturally occurring organic material that has accumulated over many years in the wet and cool places. It can be used as mulches or soil conditioners. Maintenance of soil organic matter. Crop residue incorporation is another way of maintaining soil organic matter. The second one is conservation cropping systems at zero tillage, minimum tillage. The third is the use of animal manure. And then the fourth is the alley cropping, strips of arable crops interspersed with leguminous shrubs. The use of composite is another way of maintaining soil organic matter. Green manuring, mulching, and fallowing are ways of maintaining soil organic matter. These are pictures of a well recycled organic matter in the soil. The crops as they grow luxuriantly and well fed from the soil nutrients, they discover when they die, the debris will be added to the topsoil and incorporated into the soil to improve on the soil organic matter, hence improving the soil fertility in that location. This is the end of our lecture for today. I thank you for listening. See you next week, same time. I am your facilitator, Dr. Godwin A. Alhassan. God bless you.